Any questions on this? No. Okay, now let's look at the next one. Here we have solve the equation by coupling the square. What is the first step? Yes, which is -6. Then we divide it by 2, so we get -3. And then we square -3 and we get 9. So then the equation is x squared minus 6x plus 9 equals -3 plus 9. Agreed? Now this part is, and this part is 6. And now I have to take the square root, so I have x minus 3 equals. So therefore, x equals. Excellent. Perfect. Any questions? Okay, next one. Next one. Good. So now the equation will be. Good. This should be in your notes, actually. So this is y plus 3 and y minus 1. And there are two options, -3 and 1. And then you create new equations. 5x plus 1 equals -3, which will give us 5x equals -4 or x equals -4/5. And the other one is 5x plus 1 equals 1. So then 5x equals 0, which means x equals 0. Any questions on this? Okay. And the last one. In the last one, first of all, I have to identify the fact that a is negative. So therefore, the quadratic function has to have a maximum. And then I already know the vertex. Can anyone dictate the vertex? -2, 4. Very good. So then the shape is this. The vertex is this. Will the x-intercepts exist or not? Or not? Will they exist? Do they exist or not? Yes. How do I know? Exactly. And the y-coordinate of the vertex is positive. Correct. So then I will find the x-intercepts by doing what? For the x-intercepts, what do I have to do? 4? Yes. So y equals 0 or -2 x plus 2 squared plus 4 equals 0. How do I solve this equation? I will never do that. I have 4 methods, and the easiest method to apply here is by, I will never, if it's something squared and I'm asked to solve, I will never ever distribute. I mean FOIL and square and then distribute. So I divide both sides by -2, so then I have x plus 2 squared equals 2. And then I take the square root, and x plus 2 equals plus or minus the square root of 2, or x equals -2 plus or minus the square root of 2. And yes, I will have to approximate because I don't know where to plot. So I will say x is approximately -2 minus 1.41, which is -3.41, and -2 plus 1.41 is -0.59. What about the y-intercept? F of 0. Okay, so let's do this together. How much is 0 plus 2? How much is 2 squared? How much is 4 times -2? And how much is -8 plus 4? Excellent. So then I have 0, -4. What is the axis of symmetry? No, it has to be an equation. X equals -2 is the axis of symmetry. I agree. What is the max? Max is 4. Good. So I go back to the chart. and I have to plot the vertex, which is negative 2, 4, negative 2, 4. Then I will graph or just present the x equals negative 2, which is the axis of symmetry. Then I know I have 0, negative 4. And then I have these two kind of difficult to plot. Negative 3.4. So this is negative 3, negative 3.4 is here. And negative 0.59 is somewhere here. But I have to make sure that these two are symmetric with respect to the axis of symmetry. So right now they don't really appear to be symmetric. Okay, so this is 1 and a little bit and 1 and a little bit, so that's fine. So you cannot graph the function that does something like this. You know that. It has to be symmetric, and it continues to open up towards negative infinity. Okay, so this is the graph of f of x, negative 2, x plus 2 squared plus 4. Okay, so having said that, let's go back. Any questions for me? Anything? Yes, please.
How many points did you take off the graph X-Intercept?
All of them. Just kidding. Just kidding. Just kidding. Just kidding. Just kidding. Okay? No worries. Okay. So let's go back to the review, please. On page, do we need to review anything from chapter 6?
Yes.
Yes.
Okay. So let's open on page 434. From 1 through 66.
Okay.
434. At the end of chapter 6. Okay. Are you ready to choose or not?
You're doing on the 26?
26. 26. In 26 we're given 18x squared minus 9xy minus 20y squared. And we're asked to factor. Factor each trinomial. Very good. Okay, first step. It's a trinomial. It's in descending order. Yeah, of powers of x. X squared, x, no x. Negative leading coefficient, no. Greatest common factor, no. Special product, no. 1 as a leading coefficient, no. I'm down to the very last possibility. What is that? No. That is, you're right. You're right. That is the last one. Not factorable is the last one. But I still have to try the one before the no, not factorable. Very good. So I multiply these two, but I really don't want to multiply them. I'd rather do this. And their sum is negative 9. Why am I doing this? Because I'm going to present it in prime factorization or show the prime factorization of this product anyway. I know 18 is 2 times 3 times 3. I know 20 is 2 times 10, which is 2 times 2 times 5. So now these are all factors in this product. So 2, 2, 2, 3, 3, 5. Of course, negative. But I need to use all these factors, come up with two numbers whose product is the whole thing and whose sum is negative 9. Since the product is negative, I am looking for okay, since the product is negative, I'm looking for excellent. One has to be positive and one has to be negative. Good. So let's give it a shot. I would have started with this. 24 and 15. And I'm done. 24 and 15.
And we don't have to do that one, right?
If you have a different method, go ahead. So then I know how to present this. Can anyone give us? So first of all, it's negative 24 and 15. This is the 24 and this is the 15. This is what I would have done. With large numbers, I always look at the prime factorization of the number. And once I presented, not as 2 cubed, 3 squared, and 5, because that's more difficult to see, but I'm just laying it out like that. 2, 2, 2, 3, 3, 5. And then, most likely, it will be easier to find the two numbers that you need. So can anyone dictate the new expression? Perfect. Excellent. So what do I do now? Good. So can anyone tell us what to factor out from the first two? Very good. What is left in parentheses? Yes? Excellent. What do I have to have coming out from the other two? Otherwise, I cannot continue. Just 5 will not work. 5y indeed. So then now this will be the common factor, which is 3x minus 4y. And what is left in parentheses? Very good. Excellent. Anything else from chapter 6?
Is that all of chapter 6 right there? Just that one type of problem?
No.
And what is it?
No.
Would you know what a special product?
For a binomial, for a trinomial, which one?
For binomial.
This is not a binomial though.
Yeah, I know.
Okay, so for a binomial we have 4 special products. We have the sum of squares, we have the difference of squares, we have the sum of cubes and the difference of cubes. For a trinomial we only have 2 special products. A binomial squared and a binomial squared, which is a difference, and a binomial squared, which is a sum.
Right.
Okay? Can I choose the next one?
Yeah.
Okay. Problem 80 on page 436. And that is 125 x to the third plus 27. Any suggestions here?
Would be the sum of cubes.
Very good. When you say the sum of cubes, what will you get ready?
Binomial.
Very good. Good. Can anyone identify the binomial for us?
Would be x plus 5. Or
5x. 5x plus 3.
Good. What will be the sign right here in the middle?
minus.
Very good. Excellent. First term squared. Good. The middle term.
30x.
Very good, but it does not have the 2. The 2 is from a different formula. 15x plus 9. Perfect.
If the binomial has a negative, then it would be a positive sign.
Yes. So if I have minus, then it's minus and plus. So the sequence of signs is plus, and then I have plus and minus. Minus, and then I have minus and plus. Okay, let's go back to chapter 11. Are we okay with nonlinear inequalities? Nonlinear inequalities. Are we okay with that? Okay, so here it is. So let's say negative x plus 1, x plus 3, and x plus 7, less than or equal to 0. Assuming you agree with my chart and you want to use it, is this inequality chart ready? Yes, because one side is a product and the other side is 0. Perfect. So then x is the variable in the problem. Negative x plus 1 is the first factor. X plus 3, the next factor. X plus 7, the next factor. And then I'm going to say product because I ran out of room. Okay. So x is a variable in the problem. It can be anything from negative infinity to infinity. Can anyone identify which values I have to put in the chart?
Would that be positive 1?
Of course, because negative 1 with minus in front will be 1 plus 1, which is 2.
Then a negative 3 and a negative 7.
Yes. So then in order, negative 7, negative 3, and positive 1. I agree.
You can do like
I'm sorry?
it's right on this.
X plus 7 is 0 when x is negative 7. X plus 3 is 0 when x is negative 3. Negative x plus 1 is 1, is 0 when x is 1. Now there is a 0 in the row for negative x plus 1. Where will I write it? Good. There is 1 for x plus 3 under. There is 1 for x plus 7 under.
7.
Good. Now I realize that only 2 of these linear functions look like this, coming from negative going to positive, and there is one that looks like this, coming from positive and going to negative. So can anyone give us the signs for the first one? And for the other two? Therefore, the product. Now, what happens when x is negative 7? When x is negative 3? When x is 1? Excellent. In the first subinterval, indeed, count the negatives. 2 negatives, when you multiply them, you get positive. Excellent. In the next subinterval, yes. In the next subinterval, and in the last subinterval. Now I'm asking myself, what do I pick? Which sign exactly? Negative is less than or equal to 0. Is this product ever negative? Here and here. Yes. So then the solution would be x in the interval negative 7, negative 3 union. Do we all agree with this? Okay. So then are we okay with nonlinear inequalities?
Is that all we're going to do on the test?
Wait, for the last one.
Yes.
I lost you on the last one, you started with the product.
So on the first subinterval, I have 2 negatives. When I multiply them, I get positive. In the middle interval, I have 1 negative, so the answer will be negative. In the next one, I don't have any negatives, so the answer must be positive. And in the last one, I have a negative.
Oh.
Is that okay?
Yeah, and then the x, then how did you find the x variable?
Based on this. So this has to be a negative number to be less than or equal to 0. And the product is negative here and here. That's why I picked negative 7 to negative 3, union 1 to infinity. Where the product is negative. Is that better?
Yeah, it's fine. Can we do that one?
Yeah. on page 688. I will pick 46 on 688, and it's x minus 2, x plus 2, everything divided by x plus 1 times x minus 4, and this is also less than or equal to 0. Is this chart ready? In case you want to use the chart. Yes, because we have product on one or ratio on n. I mean, here I have product and ratio on the left and 0 on the right. Good. So then I have x is the variable in the problem, which goes from negative infinity to infinity. X minus 2 is the first factor. X plus 2 is the next factor. X plus 1 is the next. X minus 4 is the last one. And here I have to write the ratio, which is x minus 2, x plus 2 over x plus 1, x minus 4. Now, please tell me which x values will you put in the chart? Yes, you're going to put negative 2, you're going to put negative 1, you're going to put 2 and 4. I completely agree. And they have to be in this order. Negative 2, negative 1, 2, and 4. The first row must have a 0 somewhere. Where will I find that 0 for x minus 2? Under 2. Where will I find a 0 for x plus 2? Good. Where will I find a 0 for x plus 1? And where will I find a 0 for x minus 4? Good. Now what happens when x plus 2 is 0? Correct. What happens when x, don't forget the test, homework, Wednesday. Good. What happens when x equals negative 1? Perfect, excellent. What happens when x is 2? And what happens when x is 4? Perfect. However, this is a simple situation because all these follow the same sign. They come from negative and they go to positive. All I have to do is just put it in. And then I just count. I see 4 negatives on the first subinterval. The sign will be good. When I multiply or divide 4 negatives, I always get positive. In the next subinterval, I see 3 negatives. On the next subinterval, I see 2 negatives. In the next subinterval, I see 1 negative. And in the last one, no negatives, positive. Again, I'm asking myself, which sign do I pick? And this tells me which sign to pick.
Negative.
Good. So then I will say then x is in the interval. Negative 2 with the bracket, comma, negative 1 with a parenthesis, right? Okay, union. 2 with the bracket and 4. That's it. Yes?
Determine when it's going from negative to positive again.
The leading coefficient. These are all lines, and this is how we graph a line with the positive leading coefficient. So it has to come from negative values. It will cross the x-axis, which means it will be 0, and then it will be positive forever. Is that better?
Yeah.
Perfect. Now you can say, well, what if I just plug in a number? So if you plug in a number between negative infinity and 2, and it's 0, you'll find negative. If you plug in a number between 2 and infinity, you'll find it's positive. That's another way. Good. So we're okay with nonlinear inequalities. I like to look at some more word problems. 59 on page 704. It says, find two numbers whose sum is 60 and whose product is as large as possible. Find two numbers whose sum is 60 and their product is as large as possible. What will you write first? First thing. Absolutely perfect. Thank you.
And then x times y is maximum.
Very good. So then the product of these two is x times y. We want to find the max of function p. But I don't see the function yet. I see two variables multiplied. I see x and I see y. I don't have a function of one variable. This is what I know how to deal with. I know that if you give me a function that is quadratic, then I will be able to find its max. If it has a max, I will be able to find its min if it has a min. Cannot have both. So what do you think we should do next? No? So I have a function, but it has two variables. I want to get rid of one of the two variables. How do I get rid of one of these two? Preferably, I would like to get rid of y. I want to make this disappear. How do I make that disappear? Say it again. No, but you're right. You're right to say, well, if I divide both sides by x, but then I don't really make I don't really make y disappear, just solve for y. But I want it out of there, not solved for y. There is something here that you see in our notes about the problem that we haven't used yet. So I know that p equals x times y. But I'm given a relationship about x and y. And I want to make this disappear. What should I do? Say it again. I have to solve this for y. So from here, y equals? Very good. So this is what I am going to replace y by. So therefore, p is a function of x now. Because it's what? X times. Very good. And I will distribute and arrange it in descending order. And now, yes, now I have a quadratic function. And I know it has a what? It has a what? Does it have a max? Does it have a min? We're asked to find the maximum of this function, so I want to make sure that I'm on the right track. Does it have a max or a min? Good. How do I find the max? What do I have to calculate in order to find the max? Negative b over 2a, which is negative 60 divided by 2 times negative 1, so this is 30. So then the vertex has coordinate 30, which is x. Y is 60 minus x. How much is y? How much is the other number so that their sum is 60? 30. What would be their product? 900 indeed. So how will you write the answer? I will write this. The maximum product of two numbers that add up to 60 is the maximum product of two numbers that add up to 60 is 900, full stop. The numbers are 30 and 30. Let's revise what we just did.